Okay, the last part of metals, we are actually looking at iron detail again. So we are mainly looking at the alloy, the iron alloy steel, because iron rust, we know that Fe2 plus can oxidize to Fe3 plus, which is the rust that we see, the reddish brown rust that we see. Okay, so iron will rust in the presence of water and oxygen spontaneously. So both water and oxygen must be there. Okay, and then rusted iron is good to know is hydrated iron 3 oxide, Fe2O3 with water molecules surrounding it. Okay, so in an experimental setup, if there's no air but there's water, there's no rusting because I need both air and water, right? There's a drying agent means there's no water, there's no rusting, right? Air and water present, there's rusting. And then if I have an acidic medium together with air and water, right, there's more rusting, or even a salt solution, right, will cause iron to rust more readily. Okay, so methods to prevent rusting, we have effectively two main methods. So we have a protective layer. This is the keyword we have to write, as well as sacrificial protection keyword we have to write. Okay, so let's look at this protective layer. Protective layer, we coat the whole iron with a protective layer, and this one will prevent water and oxygen from reaching. Okay, so examples of whole layer, we have painting. All right, if I add oil, if I add a plastic layer, if I add tin, or if I just plate it with a non-reactive method, so electroplating. Okay, so general advantages is this protective layer is quite affordable. Okay, but there are some disadvantages. The paint will peel off, right? Oil can be washed off. We need to replenish. The plastic can break and there may be rusting. Tin cans, okay, tin cans may, if there's scratches, it may rust as well. Electroplating is a little bit more expensive. Okay, so so this protective layer, generally, if I use electroplating, this one must be less reactive method usually. Okay, and then this protective layer, I cover the whole iron, okay, as well as steel, for example. Okay, the second method we have is sacrificial protection. So a small block of more reactive metal, right? So this reactive metal will corrode or will rust on behalf of iron. Okay, so common example, we have zinc. So if I put a small piece of zinc, right? Zinc, because it's higher in the reactivity series than iron, right? Zinc will rust in preference of iron. Okay, magnesium, this is usually found in ships and underwater pipes. Okay, so even if the zinc is scratched, the iron is still protected, right? Previously, my protective layer, if it's scratched or washed off, then the iron cannot be protected anymore. Okay, but for sacrificial protection, right, the less reactive, not less reactive, this is wrong. This one is the more reactive. Okay, once this more reactive small block, the small block, I don't have to cover the whole place, right? Once this small block react away or rust away, then the iron and steel will rust. So essentially, we also have to reapply or replenish, reapply, okay? Okay, sometimes alloying, okay, forming alloys can also help to prevent the rusting. The most common example is my stainless steel. So by now we have to know, steel is a mixture of iron plus carbon, right? So stainless steel, I also mix chromium and nickel. Okay, so chromium will react or form a layer with the oxygen to form this chromium oxide, and this layer is not permeable to water and oxygen. Okay, so sometimes we have our stainless steel cutleries like your knife and fork, right? This is really because there's a layer of chromium on it. Okay, so some of the disadvantages of forming stainless steel, adding chromium or nickel, right? This is a more lustrous surface, right? It is shiny. Okay, if I add nickel to it, it becomes magnetic. However, it is more expensive. Okay, same thing. Let's try this checkpoint. Okay, and then we have this one final part for your metals. We will be looking at this recycling. Okay, so generally this is really pretty standard information. Why do we need to recycle metal? This is a finite non-renewable resources. We need to leave it for future generation. Okay, sometimes, right, extracting metals is more expensive, right? So if we recycle, it could be cheaper, right? And then to extract metals, like just now you look at your iron extraction, it produces a lot of harmful gas like carbon monoxide, carbon dioxide. So if we recycle it, it can protect the environment. And then if, of course, if we recycle means we don't dispose. If we don't dispose means it reduces land pollution. Okay. Some issues with recycling generally, especially in Singapore, there's a lack of awareness. Okay, so if you look at the recycle bins surrounding us, right, these recycle bins look more like dustbin than recycle bins. Okay, so generally we need to have a more active role, right, to start to actually recycle metals. Okay, and then metals are only recycled if they are economically beneficial. Sometimes it is more expensive to separate them because we don't really separate these metals, right? So sometimes there's additional work to actually go about separating it, and then as a result, it is more expensive, so sometimes we will rather just, extract it from the ore again. Okay, alloys cannot be recycled effectively, right? Because I add is a mixture, and then I add nickel, I add chromium into it, and it is difficult, especially also with carbon, to form your steel. So it is difficult to separate them. So same thing, it could be more expensive to do so as well. Okay, and then sometimes if I recycle certain metals, because I have to extract it and all that, right, it can also lead to air pollution. Okay, so steel, this one is your most common alloy, right? This is the building block of all the building materials, your buildings and constructions that we see. Okay, so we usually verify the amount of carbon, okay, to produce different types of steel. So mild, medium, and high carbon. So you can see the percentage of the carbon increases, right? Metals, remember, they are malleable and ductile. So if I have less carbon, right, it will be more malleable and more ductile. It means I can hit it and it dense, it doesn't break, and I can pull it into wires. If I have more carbon, then it becomes tough and harder. Okay, and then these are the uses for the different steel. Okay, and then different types of steel. We have your stainless steel. Just now we talked about your chromium and nickel, right? Resistance to corrosion because chromium forms a layer of chromium oxide, which is not permeable to oxygen and water. Okay, chromium steel, same thing, right? Stainless steel is magnetic. Okay, chromium steel is non-magnetic. High-speed steel, good to know, tungsten and vanadium. Manganese steel using manganese. Okay, so again, these are all general information.